We have Gene Exter. He is from 1010 Data. He formerly did head of R&D at SAC Capital and ITG Majestic. And he got an undergrad degree at Berkeley and then a graduate degree at Cornell. He seems to be more proud of his California roots, though. But we're East Coast here, so everyone clap for Cornell. Thank you, Gene.
Okay, so we're going to walk through each line of this code. Thank you for coming tonight. I am very excited to talk to you about a niche field of financial research called alternative data research. I love this field, and it sounds like kind of a new buzzword. So it's alternative to what? It's alternative to the current paradigm of financial research. So what defines alternative data is really the data source. And so I think the best way to really get into it is start with a tangible example. Let's say we partnered with a browser company. They send us anonymous usage data from their users, and we can see what users are purchasing if they're using this browser. Okay, so there are 1 million people using this alternative browser, and so given what we can see from their actions on their browsing sessions, or actually their sort of online purchasing behavior, we can estimate the revenues of online retailers like Amazon and Amazon. Okay. This is what alternative data is all about. And this approach is not something that a typical buy-sider would think about 5 years ago, but today they may. Okay, so let's take a look at some more alternative data sets. So it's things like it's data that comes from the broader world around us. Things like point-of-sale transactions, online behavior, like from the browser example that we've talked about, purchases online, offline, obscure public records from city halls across the nation. I have worked with satellite imagery footage, counting the number of cars in parking lots, like your suggestion over there. So what's really interesting about this field is that it's very interdisciplinary. So it's bringing together a lot of, it's bringing together data science, it's bringing together finance, it's bringing together sort of, data sourcing. This field is starting to feel like a community to me. So thank you very much for growing it and being part of it and pushing the envelope. Really appreciate it, and let's keep things moving. This is a pretty bare bones presentation, but like these icons here, my wife helped me make, so thank you. That's the only pretty part of this presentation, and I messed it up because I put it too far on the sides. Anyway. Okay, so let's get into the sourcing. We can think of the sourcing as falling into 3 categories. There is direct data gathering, or creating the data sort of internally. There is buying the data, and there's just downloading the data. Costs of scraping are, like I said, very deceptive, and there are a lot of companies out there that are actually willing to sell you this data, which can be, overall, the total cost of ownership there can be a lot cheaper than running a scraping operation yourself. For example, the store opening closing data, right? There's a company that has this data, they'll sell it to you. If you're trying to find the store openings and closings of 100 different merchants, that's 100 different scrapers you've got to maintain. That's not an easy task. So on top of that, there are also companies whose job it is to run a web harvesting operation. Basically, most of the pros of building it have to do with control. When you build it, you know exactly how you're harvesting the web. So if you're worried about compliance, you've got perfect control over not breaking any rules that you don't want to break. You're also not levered to anybody for anything. And also, there's the IP transfer issue. For some funds, even the fact that they're looking at a merchant or scraping a certain site is more information than they're willing to give. But on the other end, when you buy the data, obviously one of the biggest advantages is they have the back data, right? If you start scraping today, you don't have the back data, they do. And moreover, they can help you structure the data, and they can help you just understand the data in general. Let's say we're looking at Craigslist, right? Why are there twice as many classified listings, apartment listings per capita in New York than there is San Francisco, right? But your R&D team can spend weeks or months trying to answer that question if you're doing it yourself, or you go out and you buy the data and they'll tell you that it has to do with the broker dynamic between the different cities, right? Just that piece of knowledge is a lot of cost savings right there. Okay, so a really exciting development, this idea of the semantic web. And this idea has been around for a while, but now there are actually tools that you can get, like DivBot. I don't know if anybody's heard of this tool, but what they do is they basically automatically structure the content of a web page. You point DivBot at a store listing web page, it knows that it has to look for a store opening and closing hours, the location, the address. It will automatically parse that information into the database for you, so you don't have to write those regular expressions or XPath to get to the nodes. So it actually, it's like an order of magnitude better in terms of cost and everything. Okay, so the other thing is, there's just data patterns all around us, right? And after being in this industry, I look at everything in a slightly different way. Like, is there a pattern in the serial number in this remote control? Like, is it sequential, right? Is there a pattern in that invoice? All these things make you sort of look at things in a different way, and maybe you can get some insights to help you make that investing decision. The bread and butter of most alternative data operations is still buying data, though. When you buy a data set, I think of a data set on a few different dimensions. You've got scarcity. How actively is it marketed to Wall Street? You've got granularity. What level of detail does it fall into? Like, is there user level info, or what time frequency does it fall into? You've got structured. How structured or unstructured the data is. Is it already tagged with all the tickers you want, or is it just like a raw text feed or images, right? And then there's coverage. How many stocks or geographies does it touch? I actually get more excited when I looked at potential unstructured data, because it probably has higher scarcity. A lot of insights or a lot of methods here can apply across different asset classes. Overall, when I evaluate data sets, I put a quantitative score combining all these different dimensions into one score, so it makes the evaluation of data sets a lot more rigorous, and it's worth the effort to actually have this kind of quantitative scoring system. It's a very useful tool. So in the last 5 years, I've seen a huge shift in the alternative data ecosystem. So I remember meeting with companies that are sitting on top of a very valuable data asset, and their main concern was, is it going to take time away from management? Is it going to be hard for us to set up this process to give you our exhaust operational data? Now it's basically 180 degrees difference in 5 to 10 years. Now companies are very, very aware of their data asset, and actually sometimes have unrealistic expectation of the worth of their data. There's some insights about buying the data. Treat your vendor as a provider of a scarce good. There's a huge cost of doing business, which is spending months or sometimes years of R&D time only to have the data set yanked from you. That sucks. And having a great relationship with the vendor mitigates that risk. Another is that many vendors benefit from the insights an analytics firm can generate. So there's space for that two-way conversation. It's not only just, you sell us the data, we give you the money. So finally, there's just downloading the data. So there's a growing plethora of available free data online, like the examples here. And for some reason, I've seen a reluctance in the financial services industry to use this free data. Maybe it's a perceived lack of value because it's free. But I think it's actually a golden business opportunity. Okay, now compliance. We have to address compliance. I think of this topic in two ways. There's regulatory compliance, and then there's ethics. So I actually find this field, in terms of ethics, to be very, very refreshing. I'll tell you why. Alternative data research is guided by the same principles as other investment research, right? So we're creating analysis to help investors and the beneficiaries, like pools of capital, like pension funds and endowments. We're helping them deploy society's surplus capital to the most fruitful endeavors possible. And so this is what I find so refreshing about it, is that unlike some other fields like, say, direct marketing or retargeting, advertising, in alternative data, we're actually not at all incentivized to base our decisions on information from individuals. That's because investing decisions are based on aggregated data where trends of individuals get diluted out. Also, if you're not directly trading your data vendor's stock, our data on its own typically doesn't have the coverage necessary to make it both material and non-public. So having an internal process that ties investing decisions to alternative data sets is actually an antidote to a lot of the current regulatory concerns in the investment world. So there's a great set of guidelines, actually. I found probably the most straightforward, published by the NIST with a tantalizing name of 800-122. So over the years, I've seen good scraping operations and bad ones. And so a few of the following rules make the difference between the two. 1, aim to respect the website's terms and conditions, paying special attention to when these are presented in a click wrap. If you guys don't know what that means and you're scraping, find out. Have a written policy regarding web harvesting, which addresses how incoming complaints are handled and how to limit the traffic that you generate. Be up to date with the latest laws, obviously. Most importantly, explicitly address the difference between headline risk and regulatory risk, okay? So take the word feel out of the equation and make risk analysis a quantitative exercise rather than the battle of the most persuasive paranoid person. We have an alternative data source. It's compliant, so what do we do with it? So far in this field, the answer has been predict revenues. But basically, there are other things that we can do with alternative data to generate value. On top of predicting revenues, we can predict other GAAP and non-GAAP operating measures, things like, for example, churn for Netflix. Now, typically, the process is that you have alternative data. We analyze this alternative data, we get some insights like revenue surprise estimates. We pass it on to a portfolio manager team, and they put it into their meat computer on top of their shoulders, and they combine it with a bunch of other information, and they use it and they make investing decisions. And so now you're starting to see more quant funds use alternative data automatically all the way through to the investing decisions. Also, non-equity asset classes, so for example, private equity shops could benefit from some of the same insights we're getting based on alternative data, right, during their diligence. And then some stuff that's a bit more of a tangent is internal PM development and data thought leadership. So if you're a fund and you have an internal R&D team, knowledge about how to work data can permeate from just the team of analysts all the way to the pods, the PM pods. One of the ways of actually achieving that is you have an incubation program where analysts from the pods go into the R&D team and get to learn all these alternative data techniques and data mining techniques. They go back to the PM pod, and when they were in the R&D team, they were working on a data set that then they're making investing decisions on. And now they know much more about the data than if we were to simply do some analysis and pass it downstream without passing the knowledge about how to work that data. Strategic investments, this is if you have a fund that has a VC operation. Obviously any investment that has to do with big data, having an internal R&D practice will make you much more savvy about your investing decisions. This slide addresses ideas on how to structure an alternative data group inside a fund or standalone. So let's briefly talk about some of these ideas. Okay, the inputs are the data, like scraping or things you buy from vendors, and then there's IT organization. It can be thought of as an input. We get the data, we clean it, benchmark it, debias it. I'll talk a little bit about that later in the technical part. We create the GAAP operational metrics or quant signals, create an investment thesis. Now, by definition, R&D goals are exploratory, so we build value by trying new avenues of analysis, failing at most, succeeding at some. So the data comes in, you've got a couple of groups. You've got the data acquisition group, which are the people that are going around to conferences and trying to find data, negotiating deals. We've got the analysts, the people that are running the algorithms on the data. Okay, so this is an interesting part. This guy right here, the R&D quant. So this is a role that it's a quant. So it's a person that knows portfolio optimization and knows how to create trading strategies, but they're actually not. They may be running things on a mock portfolio basis, but they're using just the alternative data to run their portfolio. So they have a really good feel of where the alpha is in the alternative data. You can't really separate the signal from the process of making the signal. Okay, so let's talk about a common technical challenge. One of the problems I constantly keep finding myself in is I have a data set, a panel of users or stores, and I'm trying to measure some kind of behavior in this panel. However, the users are constantly entering or leaving the panel, yet we'd like to analyze the data as if they've been in the panel the entire time. I'm sure some of you have been in the same situation. This is one approach that I've used before with some degree of success. So step one is we panel people into 6-month panels. To make it into one of these panels, you have to have all 6 months of data. Why 6 months? Is because it's 2 quarters, and it makes things really nice for down the line, because then once we get this correctly weighted, once we get this representative of the million people, you can then sort of send this data almost in its raw form with just a multiplier coefficient down to people that are just using Excel to analyze it, and they can successfully analyze it without running any models, and it's the simplicity that's appealing. So we create a 6-month panel of users who have all that data, and then we shift it down one. So we keep doing this. We keep doing this all the way down, and so you can, for example, you can understand that panel 1 and panel 2 have a lot of overlap of users, but panel 1 to panel 22 have less and less overlap of users. And also, there are no fixed effects that can explain this difference. So there are, for example, there's no variable to say which marketing campaign they come from. If there were, we could account for that in the model, but there aren't. So the only way we could really tell the 2 users behave in a similar way is to compare their behaviors. We can't model out the differences. So we start clustering each panel. And I like to use a multivariate time clustering algorithm. It's called PDC. It analyzes the complexity of your time series across multiple dimensions, and then you can apply hierarchical clustering to it. So now, let's say we cluster each panel into, say, 10 clusters, or 5 clusters, whatever. Now we want to create global clusters of users. Let's say we have 3 users, user A, user B, and user C. Now user A has all their data, let's say for a year. User B has only the first half of the year, and user C has only the second half of the year. So user B and user C actually have no distance metric between each other. They have no overlapping data. But during the overlap, user A is just like their behavior is very similar to user B, and during the overlap, user C is very similar to user A. Given the information that we have, let's assume that user B and user C are the same, or let's assume that we can put them into the same cluster. Okay, so there are a couple of ways that we can create these global clusters. So one is with the latent class analysis, POLCA, and the membership in the global clusters will more or less represent how, if we had all the data, if we had all the million users, how would all those users be clustered? How would all those users be grouped? So we reweigh the panel with this global cluster. And so now what that does automatically is it makes this, each panel now, we construct growth rates, more or less representative of the data that we would have seen had there been the full million users. Now what we do is construct growth rates. So kind of an index of panel 1 growth rate, month over month, panel 2 growth rate, month over month. And so you'll see back in our original example is that there are going to be months, because we have kind of a staircase where in a month you have a bunch of panels from which you can get growth rates. Well, this is great. This is almost like cross-validation, right? Because each panel is going to have a slight overlap of users, and now we're reweighing each panel to make them basically like every other panel. So what you should be seeing is the distribution of any measurement across the different panels in a given month should be pretty much identical. So this way you can measure the stability of your clusters, of your global clusters, to test whether it worked or not, right? Here is, for example, the geographic distribution of our users in month 1 versus month, say, 22 or something, right? So before we reweighted them, there was just a moving bias, okay? We're not getting rid of the bias, but we're trying to stabilize it. So here, the membership, if we're trying to figure out where our browser people live, once we stabilize the bias, we should see the geographic membership not move at all. Okay, and so this is actually a really important point I want to make, is that we don't want to create a company-specific model to remove the bias from the raw data directly. You want one model, not a company-specific model, but one global model to first remove that bias. And then once that bias is reduced, then we apply a model for the idiosyncrasy of a particular company's revenues, not to reduce the bias between your data and the population that it represents. I see a lot of people doing that, and you can get a lot of spurious correlation there because you run, for each ticker, you run a separate model on the raw data. You've got only 8 quarters worth of data. Of course, you're going to get some 0.99 or 0.98 correlations. Doesn't mean anything. Okay, so now we've stabilized the bias. What are the next steps? What do we do now? Now, we're still looking at our data. We have to make it representative of something that investors really care about. In this case, we want to make it representative of the total internet U.S. consumer population. We triangulate our stable longitudinal data against external benchmarks. Let's say the census. So the census geographic distributions are also applied to this data. So we have the census, we have the consumer expenditure survey, which measures how the U.S. spends their money. And then we got pure comps revenues, but for those, we want to leave some of those out until the cross-validation phase. So we can create a distance metric between that ratio and the ratio that's inherent in our data. Now, what's really cool here is we can reuse the global clusters for the next step. We take those global clusters because those group people together by type of behavior. And one of them could be pure comps revenues. What's a pure comp revenue? It's in this case, it would be something like an online retailer that reports all their U.S. revenues separately from, say, their global revenues. So if our data is perfectly representative of the U.S. population, we don't need to do any modeling at all to get at the revenues of this particular merchant. And we create a solution surface. We analyze. We basically optimize the coefficients, and then we test it against other pure comp revenues. So actually, you may not want to bring revenues into the optimization at all when you're optimizing the coefficients, because you want to leave those out and test against those. Ideally, when you remeasure your data, you get your revenues perfectly. So let's say geographic bias is really important for you to take out. So you would weigh that distance manually until you aggregate it into that global single distance metric. The last thing I'll talk about is trading revenues. So creating a fully automated strategy on top of alternative data, which I think is a really exciting new endeavor. So ideally, what we want in trading, in order to take a big position, we want to A, have a big revenue surprise estimate, B, be very accurate, know that we're very accurate, and C, know that the market is going to react greatly to this revenue surprise. That's when we take a big position. So what we want to do is create 3 scores in order to feed our trading engine. One is the estimate of our revenue surprise. Okay, how big is it? 2 is the accuracy of our estimate. How good are we at estimating the revenue surprise for this company? Use cross-validation, make sure you got the temporal order right and everything. And 3, very important, is the market going to care about a revenue surprise? Now, how do we get the last score? We've talked about the first 2, we got the alternative data. So the last score is, you take a look at the word revenue or sales in sell-side reports, and depending on how close it is to the top of the document over the course of the quarter, the closer it is to the top of the document, the higher the likelihood that the market is going to care about a surprise from that company more this quarter than it did in the last quarters for that company. So if the revenue surprise sensitivity is X, it's going to be greater than X if the word sales or revenue is very high at the top of the document. So let me take a moment to offer just one word of advice to the funds out there listening in this room or on tape. I suspect that in 3 to 6 years, this same kind of presentation is going to drop the word alternative from the title. You can think of it as an arms race or simply a competitive advantage. Either way, once adopted by a portion of the market, the rest of the market needs to adopt to stay competitive. No matter if you plan to make, buy, or just download the data, we should be thinking about an alternative data strategy for a fund. If you don't already have one, that is. No one would open up shop without a Bloomberg terminal or something like that. The same goes for this. I suspect in 3 to 6 years, it's not going to be about having the data. It's going to be about having a better model for the data, a higher, faster model. So it'll be more like news sentiment analysis. Everybody has the news. It's just a matter of how well you can analyze it now, how fast, how accurate. Right here, once everybody starts having this alternative data, it'll be the same thing. That's it. My aim here was really to just communicate what this niche field is all about. So if anybody has any questions.
So do you want to be in the mining business, in the distribution business? Do you want to have own gas stations? Where's the best place to be in this, using your analogy?
Well, that's a good question. A lot of people will tell you, obviously, you want to be on the buy side, right? That's the obvious answer. You want to be where the money is. But actually, I think that it takes a really, really big fund, multi-strategy fund, to do one of these things because they're really expensive, right? You're going to buy the data, you're going to buy the talent. If you're a shop that can only invest into a couple of different sectors and one asset class, you're just not going to have the scale to really create a big, exciting data operation. So when you're a third party, when you're like in that ecosystem, right, the middle person that's getting the data and analyzing it, that's a good place to be because you can achieve significant scale there. And if you can sort of tailor to the clients, all the different types of clients, you can really create something very interesting.
When you're buying the data from the companies, how do you judge how good the data is? How do you know that there's not bias in the data or even fudge the data?
Right. Yeah, it's kind of a chicken and an egg problem, right? So, let's see. I think we talked about this slide, evaluating vendors. The typical process is you get a sample. And usually samples are free or very inexpensive. You get a sample of data, and the reason vendors are typically okay with giving samples of the data is because everybody knows that the value of data is the ongoing stream to tell you about what happened this quarter, the next quarter, etc. So people are typically not too stingy with sample data. You do the best that you can, but no, it's a huge problem. You're investing like $1 million, right? You don't know what you're gonna. You know the I, but you don't know the R in the ROI, right? Yeah. That's where the art of it.
Do you come up with the exact signal definition and the window trading and basically pass it, or?
You can actually treat this information two ways. You can think of a time window around earnings and perfectly optimize that window, or you can think of informational velocity. So as soon as you get some information, you get some insight. Let's say you get some insight that Amazon's going to kill it this quarter. Okay, you can start assuming that information is going to be making its way into the market, but more slowly than information that's released on an earnings call. The velocity of the earnings call information is almost infinite, but the velocity of the information you have is much slower, but it's still making it into the market. So you can use that assumption to start timing your trade. You put on the trade immediately, and you estimate the velocity of your insight, of how long it will take this insight to make it into the market. And so then you say, once the insight is fully into the market, it's fully represented in the price. So let's have an informational velocity model based on previous insights that we've had, measure its impact on the price, and use that information to create a window around your trade. Realistically, I've done both, and it actually doesn't matter that much whether or not you trade around a window, like -2 weeks plus 2 weeks, or you start trading immediately on the information, and the information changes beyond a certain threshold, you modify your position. No matter what, you're basically going to make the same. The alpha is going to be pretty similar. Done. All right.
Perfect timing.
Thank you, Gene.